Welcome to Vertex 105 Playback Providers. In this module, we're diving deep into one of Vertex's most powerful and flexible systems, the playback providers. These are the engines behind how media is played, layered, and delivered across your production pipeline. We'll walk through several key concepts and tools designed to give you complete control over your playback flow, including how to tweak sequences for seamless timeline jumps, ensuring smooth transitions even during complex queuing. Expanded options for generative content, unlocking more creative and reactive playback scenarios. An in-depth look at the playback Z order and how it affects rendering and compositing priority. Then we'll revisit the Matryoshka principle. This time it's applied to playback structures, giving you modular nested playback control. We'll talk about how to use alternative playback providers such as playlists and shotboxes for nonlinear operator-driven content. And a full breakdown of the Playbacks window, your hub for monitoring and managing all playback activity. And finally, we'll explore playback mixing engines, or PMEs, and how they handle live and preview signal mixing for truly parallel playback options. Now, whether you're programming for live shows, broadcast environments, or interactive installations, this session will surely help you to structure your playback logic with confidence and precision. Let's get started. Let's start by discussing a common issue when jumping with the playhead into clip containers. Although the content is rendered immediately, there sometimes can be a delay, especially with large files like this 8K mountain panorama image. Now, this delay occurs because these files take some time to buffer. When I click on the timeline over this clip container, you'll notice a slight delay before the image finally appears in the renderer. Like so. Now, this is due to my system's performance and the size of the file being loaded into the RAM. The same issue arises with movie files, for example, even the highly performant HAP content here. You see? Now, if this given limitation is not managed properly, it can cause unwanted black gaps during transitions and timeline jumps. So let's optimize your content and sequences to eliminate black interruptions in rendered outputs. First, use the lasso tool to multi-select the clip containers. You do that by simply clicking and dragging from the right side over the objects you need to select. Access their video settings in the inspector and set both clips to preloaded. When doing so, you'll notice little pin icons appearing in the clip containers on the timeline, reminding us of their preloaded status. This setting permanently loads clips into the GPU and system RAM. So use it with care and only when needed, as it can consume significant memory resources. Jumping to the mountain panorama or the glamour loop should now result in fewer delays and interruptions in the rendered output. Another way of tweaking the black gaps in our renderer between timeline jumps can be found in the sequence settings. Each sequence has a default clip hold time of 50 milliseconds. This is Vertex's standard value, meaning textures continue rendering for 50 milliseconds after a clip container exits the render range before the screen goes black. By extending this hold time, say to 150 milliseconds, the overlap ensures seamless transitions between clips. Now, when moving between the clip containers, the transition is smoother, as can be seen when the larger mountain panorama overlaps the 1920 by 1080 texture of our glamour loop. It is still visible in the background, while the other is already rendered on top. And that's how you modify the clip hold time as needed to fit your specific requirements as well as your system's performance. Before we continue our dive into sequences and other playback providers, let's allow ourselves to get sidetracked by some more generative content found in the context menu of the Project Explorer's Content Manager. That's something we've brushed before, but more will be needed to demonstrate Vertex's playback features. We've already covered basic text content, but if you want to get more creative, using rich text assets can bring a new level of fun. Select the content item in the Project Explorer to make your adjustments, and now each word or even letter can have a unique font. And of course, it's also possible to import and edit rich text files that have been created by a dedicated text edit program outside of Vertex. Now, I will talk about masks at a later point, and we've already covered solid colors, but gradients are also a cool option. If the colors don't suit your style, like if you prefer a paler shade of red over this deep, lush red, you can easily change them here at content level. Adjusting texture size to something like 500 by 500 pixels will create a nice gradient square. In the Generative Content submenu, we also have test patterns available that are excellent for lining up multiple projectors and soft edge blending. As usual, here at content level, you can adjust the texture size of the test pattern and customize the various geometric features, like circles or crosses. You can also label these test patterns as you like, such as center stage. And this comes in handy when setting up and identifying multiple screens. A frequently used pattern is the UV pattern, which is useful for UV mapping. The possibilities of generic content are quite extensive, including QR codes that direct to a web page or could also direct to Vertex's web streaming service. Just enter the QR content and any smartphone will access its web page. Via generic content, Vertex can also render a web page, incorporate a video stream, or simply an image URL. Let's experiment with HTML content. The newly created content item tile here in the Project Explorer displays the web page URL. By default, that is YouTube, but let's try ioversal.com. Next, drag the content item below track 1 of our sequence, and a new track will be automatically created for our new clip container. If you want to interact with the web page in the render editor, you'll need to fight the urge of just clicking like in a browser window, because this would just move the clip container since we're still in move mode. Therefore, we'll need to change the edit mode to interact from this drop-down in the render editor in order to use the web page like in a web browser. Please note that this workflow only enables you to interact with the web page in the preview render editor window. Interaction with the full screen renderer, however, needs to be enabled on each system containing the outputs you want to be interactive. Go to System Settings, and under the Video tab, you'll find the parent category Full Screen Interaction. Here you can enable it, and mouse interaction is on by default. However, if you'd like the mouse pointer to be visible in full screen, make sure you enable Show Windows Cursor. You can also enable touch interactions for touch displays, by the way. Let's start the full screen renderer with the shortcut Ctrl F, and we're good to go for some interactive fun with a visible mouse pointer in our rendered output. In order to illustrate how Vertex handles the Z-hierarchy of texture layers, let's assume we're programming a show for a conference with multiple speakers, changing visuals per speaker over a more static background. Start by setting up the background with a gradient and incorporate our glamour loop on the track below. Due to the layering in our rendering Z order, the glamour loop is obscured by the gradient. To arrange these layers and merge these textures efficiently, take the content on track 1 that is rendered topmost and use the mask options in the Clips Inspector. Here we have a cropping feature that lets us crop the bottom so that the lower half of the glamour loop shines through. We can also adjust some softness so it is smoothly blended with the gradient. For more dynamic visuals, we can set the glamour loop to FreeSync playback mode. Now we have a moving background. Next, we'll set up the individual content for each speaker in the foreground. In order to keep our background independent from that, create a second sequence with a right-click on the Sequences Manager or from the Create menu. Access that new sequence from this dropdown in our playback editor window, and here is sequence number 2. We can drag and extend this sidebar here that lets us manage the tracks more efficiently, but our new sequence currently still lacks a track, which we can add by either the Add Track buttons or via the context menu. We could either rename the sequence for our foreground or select the track we just created and label it instead. Confirm with Enter and give it, let's say, a different color to make it stand out a little. Now, for our first speaker, that is the ever so talkative Professor Pixelator, I've already created a rich text content that we want for a lower thirds title, so let's lower Professor Pixelator. Now, this name of our first speaker shall remain rendered on top throughout his 7-minute-long speech, right? And also, Professor Pixelator needs more content covering the various topics of his speech. For instance, he will talk about Vertex for a couple of minutes before he goes on praising iUniversal's stellar customer support. Or we could also import the speaker's PowerPoint presentation. Of course, it is also possible to add cues to the sequence that control the timing of the show. And moving the playhead accidentally outside of the glamour loop or the gradients clip container will not mess with our fixed background. The background will remain intact because both playbacks are really completely independent. Vertex allows multiple sequences and playbacks simultaneously, preserving not only the various arrangements, but also the individual settings of all these things we've discussed, such as cues, FPS, clip hold time, transitions, and so on and so on. Let me explain to you what the little side tab here does, except for hosting the transport buttons, display of the current playback time, and the track names or labels. Well, we can enable or disable individual tracks altogether, or we could mute the video or mute the audio independently. Now we're finally getting to the vital point of this whole class, the Z order and track hierarchy. If we reposition the rich text clip, it will be rendered on top of the Vertex logo, as track number 1 is by default always rendered topmost. Now, regarding our sequences, it is the ID order of playbacks that dictates foreground and background hierarchy. The first created playback has got ID number 1, and it is by default in the background, and the second playback is built on top. These default settings can be changed in the project settings, in advanced mode, of course. Go to Rendering category, and the playback sort mode is down here. The default mode is ID ascending, and setting it to the mode ID descending would swap our background and foreground. Keep in mind that changing the Z value in the transformational properties of a clip would really mess up the default Z order of tracks and playbacks. To illustrate this, I'm going to move our rich text a couple of pixels on the Z-axis, and next I'll use a shortcut to rotate the camera in our render editor by holding down the Alt key while click dragging the mouse wheel. We can see what the altered Z position does to our texture that is supposed to be topmost. Now it's in the back. So it's best to leave the Z position as it were, especially when you're just getting familiar with Vertex. Let's reset the position, and also let's reset the camera angle of our preview renderer down here. Before we take a look at playlists and chart boxes, it is crucial for you to understand the matryoshka principle of playbacks, because there is a keen difference between a playback provider, which could be a sequence, a playlist, or a chart box that provides your content arrangement, and the actual playback in which it is nested. Each playback in Vertex serves as a host for one of these providers and managing transport functions like play, pause, stop, and is responsible for the playback mode and timecode handling. To create a playlist, go to the Create menu and select Playlist. Or alternatively, right-click the Playlists Manager in the Project Explorer to add a new playlist or multiple playlists as needed. Let's add one new playlist. Now, due to the growing size of project items, I advise you to switch to the Project Explorer's list view for a better organization. Select the playlist and it will appear in the inspector. You can access the playlist from this drop-down menu in the Playback editor, and now it's ready for content. The transport controls, such as the load and go to buttons, might remind you of the sequence cue sheet from our previous tutorial. And indeed, the sequence cue sheet combines both sequence and playlist behaviors. It acts like a bridge between the two worlds. Let's add some content to the playlist. This process allows you to drag and drop content items into the Playback editor. Now, our first track here in the playlist appears to be a unique blend or a mixture between a cue and a clip container. It is currently preloaded, which is indicated by the orange color, and it has got a clip assigned to it. When we select the track, we'll see it in the inspector, where its status is set to enabled. It can also be excluded or faded to the front easily by just clicking those checkboxes. Audio and video can be muted just like on a sequence track in the sidebar. Also the visibility. Various behaviors and fade modes are also accessible here. And in the track, right next to the clip's name, is its length. Presently, the length mode is set at clip length, meaning the default for a generative asset or any still image is 10 seconds, and that is the time of the clip length. This differs, however, from the track's actual length, which defaults to 5 seconds. If we switch the length mode to track length, the displayed length becomes 5 seconds. The actual duration of our track. Next to the setting is the free sync checkbox for the underlying clip that can be enabled. To access the underlying clip, hover your mouse over the clip name until it's highlighted blue. The inspector, if you click on it, will then switch from the track to the inspected clip. Currently, it's set to playback sync, but enabling free sync affects the clip, like our glamour loop. The track's transport is set to loop, allowing continuous playback, and a label can be assigned as well. The track can trigger either manually or be set to previous or follow to dictate interaction with subsequent tracks. Transition effects include crossfade or no fade at all, or the default in and out options. Additionally, scripts can be executed when the track begins, and also delays can be configured if a non-immediate start is desired, such as a few seconds of delay. Let's proceed by adding some more content. And as you can see, each content asset added becomes a playlist track. These tracks function similarly to the cues in our sequence cue sheet. The yellow highlight on track number 1 indicates that it has been preloaded and can be activated with the go to command, either using the bracket here or by selecting track number 1 directly from the drop-down. Now the playlist is running. It displays the cue ID of track number 1, and which becomes here cue number 1. There's also a remaining cue time since the clip length of track number 1 is set to 10 seconds. By clicking on track number 1, we see properties in the inspector panel. Currently, the trigger is set to manual, meaning I have to manually press play, and after 10 seconds the clip will stop and render its last frame. If 10 seconds is too long for my needs, I can adjust the length mode from the default 10 seconds to track length, which is 5 seconds. Now I'm setting the custom track length to 3 seconds, just for demonstration purposes, for all my tracks now. I'll load a video, my rich text asset, and the Vertex logo. And now by multi-selecting and holding the Control key while selecting clips, I set the length mode to track length. And instead of a manual trigger, I switch it to follow. Including the first track that was deselected, I set all selected tracks to a 3-second length. Now, when I start the playlist, it'll play each content asset for 3 seconds, automatically following without needing to manually play the next track or use the go to queue function. It'll seamlessly play each clip in succession for 3 seconds. A potential issue, however, now, as you can see, is the fade in and fade out times, as 3 seconds might be a little too short. Only 1 full second of content is rendered, with the other 2 used for the fade effect. Nonetheless, this setup effectively demonstrates the process. The last playback provider I want to show you is the Vertex Shotbox. The Shotbox doesn't have a manager in the Project Explorer's tree view yet, so we'll need to create one by selecting the Shotbox option from the main menu, Create. Now we'll find a Shotbox manager in the Project Explorer, and if I select Shotbox number 1, the inspector displays its playback provider time with same features as before, the playback length and the frames per second. And in the playback editor, you can now find the Shotbox from the drop-down menu with its first slot available. Think of the Shotbox as an extension of a playback provider for a device like a Stream Deck or a keyboard with specific triggers. When content is added, such as the Vertex logo, well, we're already set to run mode. Clicking on a slot plays the assigned clip for 10 seconds, which is the default clip length time. If the run mode is set to toggle, clicking on the slot fades up the clip and leaves it rendered until you click the slot again. When pressed, you'll see the preload time in yellow, and pressing it again fades it out. Another run mode option is flash, where the clip plays as long as the mouse button is held down. And if you release it, the timer resets. For auto mode, you can set a duration, for example, 3 seconds, and in this mode it runs for the set track length time and then automatically fades out. You can drag other assets here, creating a toolbox really. You can assign as you go. Slots can be configured in their settings to set default clip targets. Enabling the Show Buttons property lets you preload the slot with dedicated buttons that appear, or just switch it off. You can also mute audio, video, or solo specific tracks. Now, this is important. You need to set your Shotbox to edit mode in order to select different slots and adjust their settings like with any other Vertex item in the Project Explorer. You can also multi-select slots to change settings such as run mode to auto or displaying the thumbnails. You can inspect the underlying clip via the context menu. From here, for instance, we can access the playback mode of the Glamour loop and set it to free sync, allowing it to continue playing. Now, with the Shotbox looping cheerfully in the background, I want to show you what the Playbacks window does. It provides an overview of all playbacks, active or non-active alike. If I select this playback and click on Deactivate Selected, the Shotbox becomes grayed out and our screen pitch black. However, there is a difference between a playback being inactive, active, paused, or stopped. Just because a playback is stopped doesn't mean it's inactive. What does that mean? Let me show you with the help of our playback editor. Right now, the power button is switched to off, meaning the playback is inactive. In the case of the shot box, we've seen that the continuous playback runtime eventually came to a halt. Let's take a look at sequence 1. It is currently stopped with the counter set to 0, 0. If we move it here, then the playback is what we call paused. The playback counter time isn't progressing. However, the clip running in FreeSync is still being rendered. There's motion on our actual surface or canvas and therefore on our outputs as well. If we deactivate playback 1 by selecting it and clicking on deactivate selected, that playback enters a hibernation state. The playhead remains at its current position, whereas the stop playback command would reset it to position 0. And this allows me to resume the playback from there whenever I wish to activate it again. Let's talk about the transport controls. When I deactivate and then reactivate the playback, you'll notice that the playhead remains in position and the FreeSync resumes its playback. This is different from stopping or pausing the playback, as those actions would reset the playhead back to 0 and move it out of my clip container. Additionally, I have the option to deactivate or activate all playbacks simultaneously, which means everything can run at once. Next, we'll move on to a new chapter. What are PMEs? Let me once more use the nested doll analogy. The playback provider would be the smallest doll, the medium-sized doll, the playback. The PME is at the very end, the largest container into which everything flows, acting like a video mixer managing the levels between the live output and the preview in the render editor window. In every playback relevant window, there is a drop-down menu that switches between PME 1, Live, and PME Preview, which is PME number 2. PME stands for Playback Mixing Engine, and you can think of it like a video mixer with 2 faders for each playback, one for live and one for preview. The PMEs in the Project Explorer feature a green bar that shows the mix level of each PME. To illustrate this, I'll demonstrate the process using sequence number 2 from our conference. You remember Professor Pixelator, the renowned speaker? Now, before diving in his speech, I'll quickly deactivate the current playback. When Professor Pixelator begins his presentation, the playback is actively running. Now, let's suppose we want to edit or preview the next content during the ongoing playback, such as jumping from queue to queue without altering the displayed output. And that's where the second render editor comes in handy for demonstration purposes. I'll set up 2 editors side by side and add another playback editor window. These dual setups, matched in size and function, show 2 instances of our playback. The top one is for the running show, set to PME 1 live. And now I'll need 2 inspectors. I'll pin the live PME 1 to the top inspector and pin a second to preview PME number 2. After a quick setup, I'll adjust the view that all properties can be accessed and what they render can be seen. Now, with 2 instances of the same playback running at slightly different zoom levels, I'll zoom out so they all appear the same in the render editor window. Now, I'll initiate playback number 1. The conference begins. Professor Pixelator speaks, and the show proceeds smoothly. It is precisely timed. The Vertex logo appears, signaling the start of his major address. However, now the director wants to shorten the gap between the segments here, and we need to rearrange the clip container. This is where this PME preview workflow is beneficial. I can position the preview playhead and rearrange the timeline without affecting the live output. And I can't say how this dual instance of parallel playback control is a very unique, strong feature of Vertex that allows for adjustments in real time. If the director likes the changes, we can swap the live and preview states, effectively applying the changes without impacting what's currently broadcasted. Though swapping the live and preview PME is optional, it's part of a flexible workflow. And personally, I'm really thrilled by this capability to adapt the show live, allowing the changes without affecting the ongoing video and audio. So we've come to the end of this class, Vertex 105. Thank you very much for your attention. Class dismissed. Bye-bye.